So we might want to talk about how to do this in R. That was a whole lot of work to do it by hand. Of course, we have this nice code chi_square.test. First, you might want to think about how to enter in the data, and that's going to depend on how the data looks. If you have a data set called data, maybe I'll write it over here, right? If you have something called data, some data set here, and it has a list of, whether or not someone owns a cell phone, and a list here of whether or not what type of cancer someone has, and we'll say yes, no, brain, something like that, right? If we have a nice big long list like this, maybe a CSV file in R, okay, we can use this table command, and table will go through and create and take this and turn it into a chart, right? Where you've got cancer, brain, other, and then you'll have yes, no for cell phones, right? It'll create this little contingency table for you. So that's one way to do it if you have the data, if it's in these columns, okay? If you have the table, maybe it was available in a textbook or published in a newspaper or something, you can also just enter in the table directly using this matrix command. The only thing I will say is that, let me just put these numbers in here. Make sure that you're entering the numbers in the right order. So it's always going to fill the columns first. Let me just make sure I've got that right. Yeah. So this is always going to fill in, the first column, and then the next column, and then the next column. So just make sure you're putting them in there in the right order and assign that to table. Once you've got something like this saved in something called table, and again, you'll do it one of these two ways depending on how the data is formatted. The code is chi-squared, CHISQ.test. There's your table command, and then we have to add in this extra argument, correct is equal to false. By default, it'll try to do this correction term, which is not a bad thing necessarily, but it just won't necessarily match up with what will happen if you do it by hand. So this is what R is going to spit out. This is your test stat. Okay. This is, of course, your degrees of freedom. Okay. And this is, of course, your p-value. So it's going to spit all those things out for you, easy peasy, lemon squeezy. You'll notice that, with that p-value, that's essentially the same p-value that we got here before. And so we'd make all the same conclusions. The p-value is smaller than alpha. We reject the null hypothesis. We have significant evidence for the alternative. There's significant evidence to suggest that there's an association between these two variables. But of course, this might be a little bit less intense in terms of calculations, as long as you're familiar with what the code is.